Hi, welcome to my video on division of monomial square root radicals, part 1. Recall. Root a times root a is the root of a squared, which is a, and we're assuming that a is greater than or equal to 0. So root a times root a is a. Example, root 3 times root 3 is the root of 9, which is 3. Root 5 times root 5 is the root of 25, which is 5. Root 11 times root 11 is the root of 121, which is 11. So any square root multiplied by itself is that number. Root 3 times root 3, 3. Root 5 times root 5, 5. Root 11 times root 11 is 11. The conjugate of a monomial square root radical is a radical which, when multiplied, results in a rational number. So notice root 3 is irrational, root 5 is irrational, root 11 is irrational. Well, when we multiply by root 3 by root 3, we get a rational number of 3. Root 5 is irrational, root 5 times root 5 is a rational number of 5, etc. So if we have a radical of root 2, its conjugate is root 2, because root 2 times root 2 is the root of 4, which is 2. So an irrational number, which is root 2, results in a 2 when multiplied by its conjugate root 2. Root 6, the conjugate is root 6. Reason? Because root 6 times root 6 is the root of 36, which is 6. So an irrational number multiplied by its conjugate results in a rational number. Root 7, the conjugate is root 7, because root 7 times root 7 is 7. So root 7 is irrational. It's not a repeating or terminating decimal. So the conjugate of root 7 is root 7. 2 root 3, the conjugate could be just root 3. The 2 is not necessary, because 2 root 3 times root 3 is 2 times root 3 times root 3 is 3, results in a rational number of 6. Now some people might go 2 root 3 here, but it makes no difference. In the end, when you use it, it will give you a rational number. The conjugate of 5 root 11 is root 11, as long as we remove the irrational number. So root 5, or 5 root 11 times root 11. 5 times 1 is 5. Root 11 times root 11 is 11, so it gives us a rational number of 55. So the conjugate is of a square root radical is whatever's underneath the root. So the conjugate of root 2 is root 2. Conjugate of root 6, root 6. Root 7, root 7. Root 3, root 3. Root 11, root 11. Practice means work out the answers, pause the video, work out the 4 answers, and press play back to see if you're right. The conjugate of root 10 is root 10. Conjugate of root 5 is root 5. The conjugate of 3 root 2 is root 2. Again, you could have a 3 here if you want, either or, root 2 or 3 root 2. The conjugate of a half root 13 is root 13. So I'll go back to this one. You could have 3 root 2 if you want. And here you could have a half root 13 if you wish. But if you got multiplied by root 13, then the irrational number will become rational. The conjugate of 3 root 2 is just root 2. Check with your teacher. Make sure. Now we want to rewrite some of these expressions. Rewrite each. If you have root a over b, that's the same as 1 over b root a, because there's a 1 understood to be right here. So root 2 over 3 is the same as 1/3 root 2, because there's a 1 right there. Root 6 over 4 is the same as 1/4 root 6, because there's a 1 there, 1 over 4. And this is a 1 understood, so that's a 1/2 root 7. Practice means work out these answers, pause your video, work out the answers and see. Write each as 1 over b root a. So this one is 1 over 6 root 5. And this one is 1 over 8 root 11. And this one is 1 over 5 root 10. Just another way to rewrite root 10 over 5. Rewrite root A over B as 1 over B root A. And let's reverse it. Let's rewrite each. If you have 1 over B root A, that's the same as root A over B. So, examples, 1/4 root 6 is the same as root 6 divided by 4. 1 over 7 root 2 is the same as root 2 divided by 7. 1 over 9 root 13 is the same as root 13 divided by 9. Practice. Pause your video and work these out. Write each as root A over B. This one is root 5 over 3. This is root 10 divided by 6. This is root 3 divided by 2. Remember, there's a 1 here. There's a 1 there, so that's why that 1 is right there. That 1 is right there, understood. C, rewrite each. If you have x root A over B, that's the same as x over B root A. Just different ways to write it as a fraction. Remember, this is a fraction. This is a partial fraction, a mixed fraction. So right here, 2 root 5 over 3 is the same as 2/3 root 5. 5 root 6 over 7 is the same as 5 over 7 root 6. And this one is 4 over 9 root 11. Just a reminder, if you have 3x divided by 5, and that's the same as 3 over 5x, the same idea. So the root here is treated the same as the x. Practice means pause your video and work out these answers. So the answers are 7 over 4 root 2, 13 over 11 root 3, 9 over 10 root 5. So that's a 9/10 times root 5. Rewrite as extra practice. So we want 12 root 7 over 5 is 12 over 5 times root 7. 3 over 7 root 2. 8 over 3 root 14. Let's continue. Rationalizing the monomial denominator of a fraction. To rationalize the denominator of a fraction means that the denominator, which is an irrational number, has to be a rational number. That means that the monomial denominator has to be multiplied by its conjugate so that the denominator becomes a rational number. Hence the numerator has to be multiplied by the conjugate also so that the fraction is equivalent to the original. And then we can simplify the numerator and denominator, and if possible, reduce. Let's do some examples. Simplify each. So when we want to rationalize the denominator, that's an irrational number. So we multiply the bottom by its conjugate, and we multiply the top. So the conjugate of root 2 is root 2, so we multiply by root 2 over root 2, because root 2 over root 2 is the same as 1. So 1 root 2 is root 2, and root 2 times root 2 is 2. So the denominator, instead of being a root 2, is now a 2. 1 divided by root 3, the conjugate of root 3 is root 3. So you multiply the top by root 3 to keep it balanced. So 1 times root 3 is root 3. Root 3 times root 3 is 3. Again, your denominator, which is irrational, is now a rational number 3. And the conjugate of root 5 is root 5. So the top, or the numerator, is multiplied by, root 5. It has to be root 5 over root 5 to get 1 to keep it equivalent. So root 3 times 5 is root 15. And root 5 times root 5 is 5. The conjugate of root 7 is root 7. And we put root 7 on the top to balance it. 7 times root 7 is 7 root 7. Root 7 times root 7 is 7. And notice that 7 divided by 7 cancels out just to give you root 7. They cancel out 1, 1. And 6 divided by root 2, we want to rationalize the denominator, we multiply the bottom by root 2, the conjugate of root 2. So we multiply the top by root 2. Multiply. 6 times root 2 is 6 root 2. Root 2 times root 2 is 2. And 2 divided into 6 goes 3, so the answer is 3 root 2. So the denominator, which is irrational, now has a rational number of 1 when you simplify. And we multiply this one by the conjugate of 4 root 3. Could be just root 3 if you wish. Check with your teacher. Some teachers might want this to be 4 root 3. But a root 3, as far as I'm concerned, will do it. Why? 1 times root 3 is root 3. Perfect. Notice that's 4 times 1, which is 4. Root 3 times root 3 is 3. So this denominator becomes a 12. So instead of being an irrational number, it's now rational of 12. And G, the conjugate of 2 root 5 is root 5. So we multiply the top by root 5 to keep it balanced. So that's 15 root 5. And that's 2 times 1 is 2. Root 5 times root 5 is 5. So the bottom becomes, the denominator becomes 10. And this is a fraction, so 5 into 10 goes 2. 5 into 15 goes 3. So that's 3 root 5 over 2. Or you could say 3 over 2 root 5, your choice. But notice that the 10 is cancelled with the 15. You cannot cancel the 10 with the root 5 because this is an irrational number. This is a rational number. You cannot cancel the 5 with this 10. Only rational or integers can cancel. Let's continue. Practice means pause the video and work each of these out to see if you're going to get. Do one at a time to make sure you know what you're doing. Rationalize the denominator of each. When we rationalize the denominator, we multiply the denominator by its conjugate. So the conjugate of root 3 is root 3. So the top is multiplied by root 3. 1 times root 3 is root 3. And root 3 times root 3 is 3. To rationalize this denominator, in other words, when we say rationalize, we agree with teaching this that your denominator should not have an irrational number, should not have a radical. So to rationalize denominator is saying remove the denominator move the radical in the denominator. So there's no radical in the denominator. So root 5 is the conjugate, root 7 is the conjugate of root 7. So 1 times root 7 is root 7. Root 7 times root 7 is 7. So the root 7 becomes a 7. And to rationalize this one, or to remove the radical from the denominator, which means the same thing, we multiply by root 2. So we multiply the top by root 2. So 10 times root 2 is 10 root 2. Root 2 times root 2 is 2. And 2 into 10 goes 5. 2 into 2 goes once, so that's 5 root 2. So rationalizing the denominator means remove the radical from your denominator. The conjugate of root 5 is root 5. We multiply top and bottom. The conjugate of root 5 is root 5, so we put root 5 on top to balance it. Multiply, it's 15 root 5 for the numerator. Root 5 times root 5 is 5. And 5 can't cancel into, this is irrational, this is rational. So the 5 can only cancel into this number. 5 into 5 goes once, 5 into 2 goes 3. So we get 3 root 5. And the conjugate of root 6 is root 6. So the top is multiplied by root 6. That gives us 9 root 6 divided by 6. And again, it cannot cancel root 6 and 6. 3 into 6 goes 2. 3 into 9 goes 3. So that's 3 over 2 root 6. Or you could say 3 root 6, your choice. Number 6, you got to rationalize your denominator. In other words, remove the radical from the denominator. So you multiply the bottom by root 10. You multiply the top by root 10 to keep it balanced. So that becomes, the top becomes the root of 50. the bottom becomes 10 because root 10 times root 10 is 10. And root 50 is simplified because that's a 25 times 2. So that's 5 root 2 divided by 10. 5 into 5 goes once, 5 into 10 goes 2. So that's root 2 over 2. Or we could go 1/2 root 2. Number 7. We want to rationalize denominator, no radical in the bottom, so we multiply the bottom by root 3. The conjugate of root 3 is root 3. Multiply the top by root 3. Multiply 3 times 1 is 3. Root 2 times root 3 is root 6. And 4 times 1 is 4. Root 3 times root 3 is 3. So that gives me a 12. And we cancel. 3 into 3 goes once. 3 into 12 goes 4. So we get root 6 over 4. Or we could have 1 over 4 root 6. And number 8. We cannot have a radical in the bottom. We want to rationalize the number. We multiply by the conjugate of root 10, which is root 10. Multiply the top by root 10 to balance it. So that's root 20 all over root 10 times root 10 is 10. The root of 20 is 4 times 5. So that becomes 2 root 5 over 10. And 2 into 2 goes once, 2 into 10 goes 5. So we get root 5 over 5. Or we could have 1/5 root 5, your choice. Remember, that's a 1 understood. So either root 5 over 5 or 1/5 root 5. Number 9, the conjugate, we want to remove the radical from the bottom. So we multiply the bottom by the root of 21. That means we multiply the top by the root of 21. And that gives us, now notice with the bottom is easy because the root of 21 times the root of 21 is 21. But notice when we multiply these, we're going to get a large number. So if you think about it, we got a 6. So let's think about root 7 times 21. And 21 is 3 times 7. But if you multiply this and get 147, then you got to break 147 down. So why not, before you multiply these, break them down? So you get 7 times 21, which is 3 and 7. So you got 2 7s. So you take your 7 out and leave your 3 in. That's what you would have to do if you had the root of the product of 147. So it's easier to break it down first here. That gives you 42 root 3 over 21. And 21 goes into 21 once, 21 goes into that twice, so we get a 2 root 3. A little bit more complicated, just got to be careful. And number 10, 18 root 2 divided by root 15. The conjugate of root 15 is root 15. So we multiply the top and bottom by the root of 15. That gives us 8. Now, root 30 is not too bad. Let's see. Root 30 is a 2. 15 is a 3 times a 5. So that means there's no even number here. So that has to stay as a 30 because there's no prime factor. No square root factor. I said prime. These are prime factors. No, what I meant is no square root. There's no perfect square here. So root 15 times root 15 is 15. So again, 2, 3, and 5. You can't simplify the root of 30. And 15 got 3 and 5. 8 got 2s and 4s. So that's it as far as it can go. 8 root 30 over. Oh, that's an 18. Look at the mistake. I wrote that's an 18 there and I forgot, omitted the 1. Now we can, because that's an 18, 3 into 15 goes 5. 3 into 18 goes 6. So we have a 6 root 30 over 5. I made the error and omitted the 1. So if it was an 8, it wouldn't simplify. Because it's an 18, 15 and 18, you divide by 3. Again, you cannot simplify 15 and the root of 30 because that's irrational, that's rational. That brings us to the end of this video Hope you enjoyed the video. If you do, click on the like button, click on the subscribe button, and the notification bell, because there's more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, the videos, and the content. Thank you for viewing my video. Bye-bye.